Hey, and welcome back to another video of our Learning Java 2D Game Programming series. So in the last video, we made a very simple NPC player. It does not have an AI yet, so it just stands there. And so for today's video, I think that we should start implementing a simple finite state machine for the AI. However, there is some work before we can get anything fun going. So in this video, we might just be doing some setup work. And maybe we can get to some actual walking and stuff in the next video. This is probably going to be a little long anyway. But let's get to it. It won't happen if we won't do it. Let's do it. So first of all, make a package and call it AI. So in here, I'm first going to make something called an AI manager. And this is going to act as the state machine holder, I guess. The brain. This will be the brain of our players, AI players. So there are some things that we're going to need. First of all, let's make something called an AI condition. So our states will have transitions. And a transition is going to have a condition or multiple. Today, let's start with one. Let's start simple, and then we can extend it later and make it better. Let's start with one. One transition has one condition. When the condition is met, it also has a state that it wants to transition to. So let's start with a condition. Make a class called a condition. Actually, sorry, make an interface called a condition. And you'll see why later. So what this condition, this interface will have is of course a Boolean. And we can ask it, is condition met? Actually, we don't even need to say condition because it's already called a condition. So is met. Condition.isMet will be awesome. So that's really what I want. And this is probably going to need now the state, because we might need to make a condition that depends on how our state is looking. We also want to know which NPC we are. Let's just say current character. Oh, no, current character. I want current character. All right. So of course, we're probably going to need the NPC that this state machine is currently controlling. If we only sent in the state, I mean, we could fetch all of the game objects from the state, but we could not know which of them is the current character from within the condition. So we need to pass these two down to a condition. So with that done, let's make the transition. All right. And so what this will have is, first of all, a string representation of the next state that we want to go to. And I will explain, let's just say, call it next state. I'll explain why when we get to our states. And we also want a condition. All right. And when we initialize, let's make a constructor. And let's take in both of these. Okay. So let's also make a wrapper function. We're gonna need it. So a Boolean which says should transition. And we need, of course, now to take in the state, because we're gonna ask our condition if it's met. And so we need to take in the things that it needs. And sorry, we named this current character. And import. All right, so let's ask it. Return condition is met, state current character. All right, and then we also need a getter for the next state. So just generate a getter for the next state. And I think that's it for this class. All right, so now we're in the AI manager, and it's going to need a state. So let's start making the AI states. So make a new package and call it state within the AI package. And just to keep it separate from our game state, or the state that we're using inside of the game package. Let's name this AI state. And this will be an abstract class. So I got a question about the abstract classes because I use them for almost all of my base classes instead of using interfaces. And the reason I do that is, of course, that we can share implementation. So an interface can't have an implementation, of course. And so this way, if I just take as an example my game object, so all of my game objects will have positions. So I can put this implementation inside of my game object. I can say that it actually has a variable position, and there are getters and there are setters, and we could have more implementation in here, as well as these, of course, abstract methods, so that the deriving classes will have to explicitly implement these in their own ways. So that's why, to share implementation. So let's go back to our abstract class AI state. So what we need in our state is, of course, a transition into the next state. So keep a transition in here. And let's make a constructor. And actually, sorry, don't do this. So what I want to do instead is I want to say this dot transition is equal to initialize transition. And this, let's generate that. Actually, let's generate an abstract method inside of here. And this is exactly what we want, a protected abstract method. So we always have a transition, but we'll let our implementing classes decide how that transition will look like. And so they have to implement this method, which will return an AI transition. But we don't need to, sorry, I don't know how to describe it better. I hope you understand. I think this will work quite well for us. And we also need some wrapper classes here. So the state might answer, let's make it answer the fact. So a public Boolean should transition, right? And this, of course, again, needs to take in these things. So the MPC as well, current character, and just return transition, should transition, state, and current character. So if we should, we can also get right? Let's make that get next state, which just returns transition get next state. So these are basically wrapper methods, so I don't have to go in several steps to get it from this transition. And in the future, if we have a list of transitions, then we will use the active one, or the one that had its condition true. All right, what else are we going to need? Our deriving classes are going to need an update method. So that will be void update, and it will probably use the same things here. So the MPC, the state and the MPC, current character. All right, I think that this is good. Let's go to our AI manager and let's start implementing this. So it first has a current state, right? So an AI state, current state. And let's see, is that it? So alt insert constructor. All right. What else will it do? This needs an update. So public void update, which also uses the state and the MPC current character, and make sure to import those. And now what we want to do is we want to check, first of all, current state. Let's see, did we have should transition or next state? But we won't know that unless we have, this needs to be public. Okay, so this, we want to use this from our AI manager. So current state, update, using the state and the current character. So that will always happen. But now let's check if current, state should transition. And it uses these things to figure that out. So if it should, then let's do transition to, and we're going to make this method. And then get the state dot, current state. See, I'm already getting confused that I've named them both states, so we might actually want to fix that, but one thing at a time. So the current state, the AI state, get next state. Maybe we should actually call it that, so we are current AI state. Current, yeah, sure, rename. Okay, good, so we can keep track of it. So, okay, so create method transition to. And then let's do a switch statement here. So switch on next state. All right, so case, and we're gonna make a stand today, but let's also make the default is the same. So this just means that these are both gonna use whatever comes under here. And so I think that our current AI state is gonna be a new, no, sorry, that's probably, yeah, current AI state. It's gonna be a new stand, and we don't have that yet. So let's make this stand, which will implement the AI state. So new Java class, call it stand, which will extend AI state, Alt enter, implement those methods, right? And what we want to know in here is, of course, let's do private int updates alive, maybe? We can always change that later. So in here we want to do updates alive. So since we started standing, for how many updates have we been standing? That's what this is going to be able to answer for us. So we're going to make a new AI transition, and we'll do that this way, new AI transition, and we're going to implement other states in the next video. So for now, we're just going to go from stand to stand. But we need a condition. So you can actually make one in this sort of lambda way. Current character. Can we not? Why is it sad? State and current character, exactly. All right. I needed an extra, sorry, of course, I needed an extra parentheses. And so this way, instead of saying like new AI condition, since this is an interface with only one method, we can instantiate a new type or an implementation, something that implements AI condition in this sort of lambda way. And you can do that if the interface only has one method. Okay, so the method is, of course, is met. And in order to be able to answer that, I will say if updates alive, which we can say because we have the updates alive up here, is larger than or equal to. And the thing now is that we need to know for how many updates. I mean, we could always hard code it this way. I want to be able to ask it for seconds, right? Which means that we need to, I'm just going to see how long I've been doing this, and I've already been going for 15 minutes, but whew, let's make something real quick. Let's make a new class inside a game, call it a timer. And we're going to use this later to be able to tell, well, for how long our game's been running and things like that. But the things that we want this to have is updates since start. And yes, we also want this to keep track of, let's do that later. Yes, alt insert, make just a constructor. And we didn't want that. It's always going to start at 0. And then we can ask the timer get updates from seconds. This will take in an int seconds. It will return seconds times. And let's do this. So inside of the game loop, it keeps track of how many updates we've set per second. So let's just start by making that a static variable that we can find, because we don't want to change it anyway when we've started. It's not going to be dynamic. It's going to be, yeah, it's going to be static. So let's make it static. So public static final int updates per second. All right, and then we need to set that to 60. So, and put that there. This means that now inside of our timer, we can use it. So when we ask it, we want to do something for this many seconds. How many updates will that be? That's what this will answer for us. So the timer, of course, now we need to make it, put it inside the state. So protected time. We called it timer. I probably want to call it time instead, because timer, it's not the only thing that it's doing. Not sure. Call it time for now. All right. So inside of our state, we'll have a time, import it, and initialize it. New time. All right, we need to do a getter. So alt insert, make a getter for our time. And now inside stand, since we have the state, we have the time. And we can now ask it to get updates from seconds, and let's say 3. Okay, so now we don't know. I mean, I guess we could have fetched the static variable from the game loop from within here instead of making this time object. I really only did this because I know we're going to use it later to display our game time, to do other things. So halfway there, you know, a little bit at a time. All right, now this transition should work. And we've updated our time alive. Let's go to our manager. And now we have a stand, so let's import it. And do we need to do anything else? Let's just say transitioning to, and then let's give it the next state so that we can see this. And the AI manager is taking in a state. Let's not do that. Let's just do transition to stand. My thinking is all over the place. We don't need to set it, of course. We're doing that inside of the transition. So when we make an AI manager, we transition to stand. And the stand is creating a new stand. Inside of my stand, I have a transition. And currently, it transitions to stand. So this will just transition to stand in an endless loop until we have more transitions and more states to transition to. But now we need to use this AI manager, and I'm hoping that this video will be done very quick soon. So let's just make a AI manager inside of our MPC. Let's call it AI manager. Okay, and now in our update method, which we'll need to override. So public void update, which now needs to take in the states, which means we're gonna need to fix that in our other places. But now we can say AI manager update, and then you use the state, and then you pass in this. Also, we need to call super up date, and it's gonna be using a state in now. Okay, this now needs to have the state, and we would be needing that in the future anyway. So let's just add it to all of our updates. And NPC has it, and so for now we're not doing anything in the, let's just remove the update method until we are implementing something in it. All right, so hopefully the AI manager is getting updated. Also, we need to initialize it, of course. So AI manager is equal to a new AI manager. All right. Let's just see if this very simple finite state machine is working. And of course, we need to pass in the state when we update. That's what that said. Okay, so it said transition to stand. And now it's also transitioning to stand. And again, with 3 seconds apart. So this worked well. Now we have done a lot of setup code so that in the future we're going to be able to create more states more easily. In the next video we will make our guy walk, and hopefully that video will be a little bit shorter. So thank you, Arl, for coming with me, and I'll see you next time. Hej då!